So hello friends, today we are going to solve delete a mid element from a stack. So given a stack S, delete the middle element of the stack without using any additional data structure. So we have to just delete the middle element without using any extra space. Okay. So note the output shown by the compiler is a stack from top to bottom. Okay. So input is stack that is 10, 20, 30, 40 and 50, and we have to delete the middle element from the stack, right? So for example, the size is 5, so middle element is 30. So we need to remove the middle element from the stack, that is 30, and again we have to again return the stack. Okay. So the second example is 10, 20, 30, 40. In that case, the 4 divided by 2 is 2, so we have to remove the second element. Okay. So the second element is 20, so we need to remove the 20 from the stack given. Okay. So for example, see, for example, we have a stack like 5, 2, 1, 0, and 7. Okay, so we solve the problem using recursion. So first element, that is for example, the first element is 7. So we have to reach till 1 and we need to pop that element. Okay, so what we will do, first we will take count variable. First we will take count variable. Okay, so initially our count is 0. Okay, initially your count is 0 and we will store the element somewhere, that is 7 is stored is somewhere. 7 is stored and we will pop the 7. We'll pop the 7. Okay, we'll pop the 7 and store somewhere. Okay, so 7 is popped out and it is stored somewhere. Again then we will increment the counter by 1. Okay, increment the counter by 1. Now our counter is 1. Is it, and always we will check if it is reaches to the middle or not. Okay, if it is reaches at the middle of the stack, no. So we will again store again we will pop the top of the top element and store somewhere. So 0 is stored somewhere. So 0, and we will pop the top element now. Okay, now our count is 2. Initially our size is 5, so 5 divided by 2 is 2. So now we reached at the middle of the stack. Okay, so we need to remove the 1. Okay, we need to remove the 1, only pop. Okay, we'll not store the 1 anywhere. Okay, so we'll pop the 1. That is our base case. Whenever the count is equals to size by 2, this is our base case, and we will remove that element. Okay, so 1 is removed. Okay, okay, 1 is removed. So what we'll do then, after that we will again push the element that are stored somewhere. Okay, so again we will push the 0 into the stack and 7 into the stack, and we will return the stack. Okay, we'll return the stack. Okay, so this is what the approach. For example, we will try to okay, we will use, okay, there is okay, so okay, so for example, initially we have 7, initially we have 0, then we have 2, then we have 5, it is suppose, and we have an 1. Okay, so I will just erase the bottom one. Okay, okay, so we will call some function and we will pass count. Okay, sorry. Okay, so initially we will call some function and we will pass the count variable in it. Okay, so for example, here our count is equals to 0. Okay, our count is equals to 0. Count is equals to 0 initially. Okay, initially when we call the function, so our count is equals to 0, and we will check is count is equals to n by 2, that is size of the stack divided by 2. No. If no, Then what we will do, we will store the top element somewhere. For example, then the top element will be stored somewhere, and it will be like, let us suppose it is equals to 7 is stored, that is 7 is stored somewhere. Okay, so 7 is stored somewhere, and I'll just highlight it. Okay, now 7 is stored somewhere, right? Now our, okay, 7 is stored for the call, and we will again, 7 is stored. Okay, and we will again call the same function with the rest of the stack. Okay, now what is stored in the into the stack? Now it's 0, it's a 2, it is stored and also popped out. Okay, then 5 and then 1. Okay, and now our count, now our count now our count is equals to 1, as one element is popped out. Okay, is count equals to n by 2? No. Then what we will do, again we will store the top element and we will pop out it. Okay, so our the element, now the element that is popped out is 0, and it is stored somewhere. Okay, so now our stack is looks like 2, 5 and 1. Again we will check, again we will check if the count, if the count is now 2, and count is equals to n by 2, that is total size initially it is 5, so 5 divided is 2. So yes, we need to remove the 2 element from the stack. We don't need to store somewhere the element, we doesn't need to store somewhere. Okay, so we'll just remove the top element. Okay, so 2 is removed. Now we will pop the 2 and just so let us suppose 2 is now removed. Okay, so what we will again do after that, we will just simply return. Okay, we'll just simply return, and whenever we return, we will push the element that is popped out. Okay, and we will store it somewhere. So our stack is now 5 and 1, and again what we will do, we'll push the 0, we'll push the 0, and now the stack is 1, 5 and 0. Again what we will do, again we'll push the 7 onto the stack. Okay, this is what our answer looks like. Okay, this is what our answer, and 2 is removed. Okay, hope you understood what. Okay, we'll code for the same. See, now first thing is we need to store the int, that is a size of the stack, that is s dot size of. Then we need to maintain a counter, that is count, initially it is 0, and we will call some function to solve the problem. So, we will pass the size of the stack, then we will pass the count, and we will pass the size. Okay, size of the stack. Okay, and so here we will write the function, that is void solve. Initially we will, okay, there is a stack, then there will be a count, and there will be a size of the stack, which is always constant. Okay, so what is the base case? So base case is whenever the count is equals to n by 2, at that point we need to pop out the top element. Okay, and return. Okay, so we'll write here if, that is base case. Okay, base case base case is if our n by 2 is equals to, if n by 2 is equals to count, that time we need to pop the element. Okay, only pop. Okay, so s dot pop up and just return. Okay, okay, if that not the case, in if the n by 2 is not equals to count, in that case what we will do, we will just store the 7 Okay, top element 7 now, 7 or 0, whatever the top element will be. We will store the top element. Okay, so we write over here int num and is equals to s dot of, and just we will s dot of, remove the element. And what we will do, we will again, now the whenever we remove the top element, our stack will looks like 20251. Okay, and count is incremented by 1. So again we will call the same function recursively, that is the stack. Okay, and now count is count plus 1, and it will be the size, which is always constant. Okay, which is always constant. And whenever it solves the function, what we will do, we need to return. Okay, and whenever it will return, for example, from here to here, so from here to whenever the top element is removed, we will again call the same function. Okay, we will be reached into the same function. And yes, 0 is already into the num variable. Okay, 0 is into the num variable. So what we want to do, we want to again push the whatever the num into the num. Okay, so we'll just push the element onto the stack, is dot push and num. Okay, this is what okay, so this is done. We try to run it. Okay, there is a problem, that is a stack and function as, okay, what is the problem? Okay, we need to write end count and end. Okay, so yes, it's running well for the, now we try to submit it. Yes, it will pass all the test cases. So thank you so much for watching the video.